Protein shakes have taken the fitness world by storm, evolving from a niche bodybuilder staple into a multi-billion-dollar lifestyle product found in every grocery store. But are they truly beneficial biological tools or just expensive marketing hype? What do they really do to your cellular machinery, particularly regarding muscle protein synthesis and metabolic rate? Today, we're delving into the neuroscience and biochemistry of protein shakes, cutting through the industry noise to uncover the physiological reality, potential systemic pitfalls, and how to manipulate their effectiveness for your specific health goals. To grasp the potential benefits of protein shakes, we must first understand their molecular composition. Essentially, protein shakes are isolated macronutrients derived from food sources. Whey and casein come from milk processing. Whey is the liquid byproduct of cheese production, known for rapid absorption, while casein forms curds and digests slowly. Plant-based options like soy or pea isolate specific proteins from the raw vegetable to provide a complete amino acid profile. Protein is the building block of life, but specifically, it is a chain of amino acids. 9 of these are essential, meaning your body cannot synthesize them. They must be ingested. These acids are crucial not just for repairing muscle tissue damaged by mechanical tension, but for synthesizing enzymes, neurotransmitters, and hormones, and fueling the immune system's production of antibodies. However, are these processed isolates necessary if you already consume a balanced diet? Let's delve into the metabolic difference between drinking your protein versus eating it. When you consume protein, your body utilizes hydrolysis to break complex chains into single amino acids. One specific amino acid, leucine, acts as a molecular switch that triggers mTOR, the primary signaling pathway that tells your body to start building muscle. Without enough leucine circulating in your blood, muscle repair cannot efficiently begin. This process builds stronger myofibrils, muscle fibers, but it also drastically affects your metabolism through the thermic effect of food, TEF. Protein is metabolically expensive. Your body burns roughly 20 to 30% of the protein's calories just to digest and process it, compared to only 0 to 3% for fats. This means eating protein increases your daily calorie expenditure, even at rest, simply by forcing your digestive system to work harder. Protein also aids in weight management by manipulating your hunger hormones. High protein intake has been shown to suppress ghrelin, the hunger hormone, while boosting peptide YY and GLP-1, satiety hormones. This chemical cascade signals to your brain that you are full, potentially reducing your spontaneous daily caloric intake without the need for willpower. However, the question is, can these metabolic effects be maximized specifically through liquid shakes? Protein shakes offer superior convenience and bioavailability. Whey protein, for example, spikes blood amino acid levels faster than almost any whole food, making it a highly efficient delivery system. But here's the catch. The food matrix matters. For those consuming adequate protein through whole foods like steak, eggs, or lentils, shakes may offer diminishing returns. Whole foods provide a slow, sustained release of amino acids and come packaged with micronutrients, zinc, iron, B12, and essential fiber that regulates gut health and blood sugar. Shakes often lack this nutritional density. Relying too heavily on shakes can lead to a nutrient displacement effect, where you hit your protein macros but starve your body of the vitamins and minerals essential for long-term health. For specific populations, however, the concentrated nature of shakes is superior. For vegetarians and vegans, getting a full spectrum of essential amino acids can be calorically expensive with whole foods alone. Shakes can fill these dietary gaps without adding hundreds of extra calories from carbohydrates. Timing plays a crucial role, but perhaps not in the way bro science suggests. The idea of a 30-minute anabolic window post-workout is largely exaggerated. Your muscles remain sensitized to protein for 24 to 48 hours after training. However, consuming a rapid-digesting shake post-workout does quickly saturate the blood with amino acids, shifting the body from a catabolic breakdown state to an anabolic building state faster. More importantly, research suggests protein pacing is the optimal strategy. The body has a limit on how much protein it can use for muscle synthesis in one sitting, roughly 20 to 40 grams depending on body size. Spreading your intake across 4 to 5 meals keeps the mTOR signal turned on throughout the day, whereas dumping all your protein into one meal leaves hours where muscle breakdown exceeds synthesis. Not all protein consumption leads to muscle gain. Effective results depend entirely on the mechanical stress signal provided by resistance training. You cannot drink your way to big muscles without the workout stimulus. There's also a persistent myth that high protein intake destroys the kidneys. This stems from the fact that kidneys filter nitrogen, a byproduct of protein metabolism. While high protein does increase the filtration workload, hyperfiltration, long-term studies indicate this is a normal adaptation for healthy kidneys, not damage. The concern is valid mainly for those with pre-existing kidney disease. Protein shakes can be a uniquely valuable tool for older adults. As we age, we develop anabolic resistance, meaning our muscles become less sensitive to protein signals. An older adult might need 30 to 40 grams of protein to trigger the same muscle-building response that a 20-year-old gets from 20 grams. Shakes provide a way to hit these higher targets without needing to consume uncomfortable volumes of food. When choosing a protein shake, look for whey isolate if you are lactose sensitive, as it filters out most milk sugars, or hydrolyzed options for fastest absorption. Be wary of amino spiking, where companies add cheap, non-essential amino acids to artificially inflate the protein count on the label. Always check the ingredient list for excessive fillers or artificial sweeteners that might disrupt your gut biome. Here's what you need to remember: convenience versus density. Shakes are an efficient tool for hitting high protein targets, especially for fighting anabolic resistance in aging or supporting vegan diets, but they lack the micronutrient matrix of whole food. The metabolic cost: protein boosts metabolism through the thermic effect of food, TEF, and regulates hunger hormones like ghrelin, but whole foods do this even better than liquids. Protein pacing: total daily intake matters most, but spreading that intake into 30-gram doses every few hours optimizes the mTOR growth signal better than one giant meal. Quality control: ignore the marketing on the front of the tub. Read the back. Look for complete amino acid profiles and minimal artificial additives. If you found this video helpful, be sure to explore our other videos where we delve deeper into the science of health and nutrition, providing you with the insights and information necessary to make informed lifestyle choices that promote health and well-being.